In this lesson, we'll learn about the concept of topology and how it relates to 3D graphics. When creating geometry in 3D applications, we'll use polygons, NURBS, or subdivision surfaces. Whatever type of geometry we use, it will be made up of either patches or components like points, edges, and faces. The way these components are connected together and the flow around the surface of the object, well, that's the object's topology. The topology is not necessarily related to the shape of the model. As you can see, we can create a sphere using a variety of different topological flows. For polygonal geometry, we can think of topology in terms of the type of polygon faces, the type of vertices, and the flow of the edges. Polygon faces can be three-sided triangles, four-sided quads, or n-gons that have 5 or more sides. Now, depending on your pipeline, there may be a requirement for geometry to only be triangles or quads. Vertices can be defined by their valence, or number of edges flowing from that point. Vertices will often have 3 or 4 edges attached to it, but it may have more. A pole is a vertex with more than 4 edges flowing into it. These points occur when geometry flows down into a single spot, as on the ends of a sphere, or when trying to merge together edges flowing in from different directions. Now, poles can be problematic because as we smooth the geometry, adding more and more polygons, the poles will never be eliminated and can cause visual artifacts. Now, in some cases, poles are just unavoidable. And in these cases, it's often advisable to move those poles to less conspicuous locations or areas of less deformation. The flow of edges is an important aspect of topology, as it lets us define shapes in various ways and allows us to create models that will deform in very specific ways. This can be especially important when building characters. For instance, we may need a model of a character to smile for a particular shot. The face may look fine in its default state, but as you can see, modeling a smile with this character will be difficult because of the poorly laid out topology. We can use a variety of tools to reroute the topology to better accommodate the type of deformation that we want. By building the face with an edge flow that mimics the muscles and skin of the face, we're able to get a more natural looking deformation. Other areas to be aware of for the topology are places like joints and areas of defined musculature. So when you're modeling, make sure to think about your object's topology and how you can modify it to get the best shape and deformation.